Yeah, I'll erase that one. Okay, so let's begin. Now this is notes 4, 9. Okay. And this is the tangent function. We're going to graph. Okay. Now what we're going to do is by hand, we just expected to know how to graph the parent function. So sine, cosine, and tangent. All the other ones, like when you start shifting and doing stuff like that, we're going to use our calculators. But the first three, we got to know how to graph them. Okay, so this first one, this would just be y equals tangent of x. Okay, just how do we graph this? Okay. So use your, be liberal here with your paper, like you want to use space here, okay, to draw this graph. That way it's not too squished for you. And this time it is going to be equal lengths on both sides. I'm going to try that line again because it didn't come out very straight. Okay, there we go. Okay. And you're looking at your unit circle. What we're going to do is we're going to write every 45 degrees. Okay, so from 0 to the first one, that's 45 degrees. What is 45 degrees in radians? Look at your unit circle. Pi over 4. Do you guys see it? Okay. That's pi over 4. This is important for you to understand what each one of these is. Now if I do another 90 degrees, okay, so right here we went from here to 45 degrees. If I do another 45 degrees, what is the radian measure right there? Pi over 2. Okay. We're doing every 45 degrees. Now I know a lot of you already caught on to this, but I need to make sure everybody understands. So let me see if I have a unit circle pulled up. I don't think I do. Okay, so here's what we're doing, guys. We're doing, right, from here to here, 45 degrees, pi over 4. I do another 45 degrees, pi over 2. I do another 45 degrees. You get what we're doing? Yeah? Okay. Now, this all makes a lot of sense if you think about it. Each one of these is a fourth of a pi. So 1/4 of a pi, 2/4 of a pi, 3/4 of a pi, 3/4. Okay. Notice this would be 2/4 of a pi, right? Because it's 2/4. What? 2/4. What does that reduce to? Pi over 2. That's why we write pi over 2. Okay. What would be 4/4? Think of a real pie at Walmart. 4/4 of a pizza would be a whole pie, a whole pizza. It's a 4/4. Okay. I mean, you can use the unit circle, 100%. I'm just showing you so it makes more sense to you. Okay. Each one of these is a fourth. So 1 pi and then 1 more fourth. So 4/4, 5/4. See, 5/4, and then another fourth would be 6/4. But we can reduce 6/4, right? Those two reduce to.
I have some white eye, borrow.
Some what? What? I don't. I'll look here in a second, but I don't have to look for it. 3 pi over 2. Right, but that was really 6 pi, and then another fourth, so 7 pi. And then 2 or 8/4, right? So 2 pi, our whole way around the circle. Okay, and then we do the same values but backwards. So negative pi over 4, negative pi over 2, negative 3 pi over 4th, negative pi, negative 5 pi over 4th, negative 3 pi over 2, negative 7 pi over 4th, and negative 2 pi. So it's important you know where all these numbers are coming from. Okay. If I had a colored printer, I would have printed these for you in color. But on your Chromebook, you can see them in color. So the purple boxes, those are your tangent values. Okay, so we're going to extract those tangent values. So you guys tell me at 0 radians or 0 degrees, what is the tangent value? What's the value in the square? 0. You guys see it? Everybody see it in the square? 0? 0 at 0? Okay, what's the tangent value at pi over 4? This can help seeing this. Let me see. It is 1. Okay, I just want to make sure you get it. Look, guys, right here at pi over 4, tangent value is 1. Okay, now we're going to go negative pi over 4, so go backwards. What's the tangent value there? Negative 1. Okay, so it's the same if you go forwards or backwards. Okay, so 1, negative 1. So this one is 1, and then this one is negative 1. Okay, what is the tangent? Look carefully. What's the tangent value at pi over 2? What's the value in the square at pi over 2? Okay, undefined. This is where tangent's different. Okay, tangent's different than sine and cosine. Undefined means we can't touch it. It doesn't exist. In other words, there's the asymptote there. Okay, we already talked about asymptotes in the past. They're like walls that you can't touch. So we have an asymptote at pi over 2 and at negative pi over 2. Okay. Now if we connect these dots, this will get forever close to that asymptote, but it will never touch it. And this will get forever close to that asymptote, but it will never touch it. So, ladies and gentlemen, this is this is the segment of the tangent function that's original. Okay, after this, it just repeats. So from here to here, okay, that's how wide it is. Remember, we call that the period. Okay, if this was a computer, you can copy and paste this to the right side, copy and paste this to the left side. Let's do that real quick. So, negative 1, 1, asymptote. Copy, paste. Okay, copy, paste to the left. 1, 0, negative 1, asymptote. And it just does this over and over and over and over, just like sine and cosine. Okay, but this one right here in the middle, that's the original. Okay, after that we just copy it over. Does that make sense? Okay, so what is the period of the tangent function? How wide is this? Now let's just use common sense. Think of a pie at Walmart. From here to here, it's half a pie. From here to here, it's half a pie. So how much is half a pie and half a pie make? 1 pi. So it's pi. The period for the tangent function is pi. That's how wide it is. It's pi wide. We're good? Easy peasy? Okay. For tangent functions, remember amplitude was the loops, right? Like how high those loops are. There is no loops here. There's no maximum or minimum. Okay. So whenever you see amplitude, you will put none. For tangent, automatically, it doesn't have any. Okay. It also, because it doesn't have the maximum or minimum, there's no midline. Midline equation. There's also none. So for all the tangents, you could automatically put none for those two. Okay. What we do have for tangent is vertical asymptote. Okay. A VA, vertical asymptote. So we do have a vertical asymptote. That's what's different. I'm going to put over here, so for period, the formula, okay, to find the period of a tangent function is very similar to yesterday's. Does anybody remember off the top of their head yesterday's? For sine and cosine, how do you find the period? 2 pi over, yeah, this one's really similar. Very similar, but instead of 2, it's just pi. Okay, so it's almost identical, just not 2 pi. And the reason again is because the period for this is just pi. Okay, so that's how you find the period. Okay, what else? We need to talk about the domain and the range. I forgot to talk about those on when we did sine and cosine. Okay, but here's the domain and then the range. But before I can do domain and range, let's talk about this asymptote. Okay, so the asymptote, this wall is vertical like this, so it's happening, or the way you write an equation is x equal, because that's how you get a vertical line instead of y equal. And then it happens at pi over 2, but not just at pi over 2. Okay, it happens again here, and then again here. How wide is that here? How wide is this space? Pi. So it's happening at every 1 pi, another pi, another pi, another, at every pi. So the way we say that is pi, and then we put an n right here. N has to be an integer. Integer is like a whole number. Okay, whole number. So it's just fancy math way of saying plus 1 pi, plus 2 pi, plus 3 pi, plus 4 pi, plus 5 pi, plus 6, so on and so on. Okay, so that's how you write. Does that make sense, guys? So the asymptote, this is how we write it. So when you write the asymptote for these, you find out where it's starting and then just add plus n pi. Good? Are we good? Okay. So I had to explain that first to explain to you the domain. So the domain will be all real numbers except where the asymptotes happen, right? Because there's walls right there. So we say except for x cannot equal pi over 2 plus n pi. So that's where sorry, you guys can't see there in the back. That's where this, right? So where the walls are, that's not the domain because you can't, there's walls right there. Now the range, all these do go down forever, up forever. So the range will be all real numbers. Okay, kind of heavy, a little heavy. Okay, it's not kind of foreign ground for us. Okay, guys, that sets up kind of just the basic foundation for graphing tangent. Any questions right now that you guys have? No? Okay, I'm going to separate this video.